All right, we are moving right along in chapter 1. Today we're looking at division of segments and angles. So first let's talk about some vocabulary terms. A point, segment, ray, or line that divides a segment into two congruent pieces bisects the segment. So if you think about a bicycle having two wheels, when I bisect the segment, I'm splitting it into two equal pieces. And that point where the division happens is called the midpoint of the segment. Now, only segments can have midpoints because they have a definite beginning and end. Rays and lines are infinite, so they can't be bisected. I can't take half of infinity. And then similarly, if there are two places where I'm dividing a segment into three congruent pieces, that is trisecting the segment. So a tricycle has three wheels. So to trisect means to split into three equal pieces. And then those points where the division happens are my trisection points. And then again, only segments can be trisected because rays and lines are infinite. So let's look at this example 1. We're going to name the congruent segments from the given information. So the first thing we're told on part A is that point O is the midpoint of segment CD. So the only thing that we're able to draw a conclusion about is segment CD. If O is the midpoint, that means this is the place where the bisection is taking place. So it's being split into two equal parts. So those two congruent parts are now segment CO and segment DO. Those are congruent because the midpoint splits it in half. Then on part B, we're told that segment SW bisects segment XV. So where those two meet at point W, it divides it into two equal parts. So XW is congruent to VW. And because W is that point where the division takes place, W is the midpoint of XV. Okay, so just the way that segments can be bisected or trisected, angles can also be bisected, meaning they're divided into two, or trisected, meaning they're divided into three. And we call the dividing bisector or trisector rays. We name them as rays. So when it's bisected, I get two congruent angles. When it's trisected, I get three congruent angles. On example 2, we are going to name the congruent angles from our given information. And on part A, we're told that ray RO bisects angle NRP, which is right here. So RO is splitting this angle in half, which means right here are my two congruent angles, and let's name them. That would be angle NRO and angle PRO. Those are my two congruent angles. Okay, on B, ray XT and ray XV are trisecting angle SXW. So that's the large angle that was split into 1, 2, 3 equal angles. So let's name them. I've got angle SXT, angle TXV, and angle VXW. So because I have all three that are congruent to each other, I can just put that in one statement. Because all three angles are congruent to each other. Then on example 3, we want to name the angle bisector. We want to name the ray that does the dividing. So we have to look at our given information. On part A, all I'm given is this diagram, but look, I've got tick marks on this diagram that tell me angle VJG and angle HJG are congruent. So if those two angles are congruent and together they're making this larger angle, FJH, that means that FJH was split in half or bisected by this piece JG. So we always say that rays do the bisecting, so ray JG bisects angle FJH. Similarly on part B, I'm told that the measure of angle POK is equal to the measure of angle MOK. So that means that those two angles are congruent, and I'm going to mark that on my diagram. So if those two angles are congruent, that means that this larger angle POM was split in half or bisected, and the thing that does the dividing is KO, or OK. So ray OK bisects my larger angle POM. Okay, now let's do some mathy problems like what you're going to see on your homework. On this first one, the points H, I, J, and K all lie on the same line segment in that order. So I'm going to go ahead and start drawing that. I've got a line segment with 4 points. H, I, J, and K. And then we're told the ratio of the lengths for H, I, J, and JK, it's 5 to 4 to 1. If HK is 40 long, so altogether HK is 40, find IK. We want to know the length of IK. So when you see ratio like this, 5, 4, 1, or sometimes even just two numbers, what I want you to do is add x to the end of each of those numbers. So you're going to have 5x, 4x, and x. And then in that order, H, I, J, J, K, that's going to represent the lengths of those 3 pieces. So I can now see visually that those 3 pieces together are going to add up to 40. So I can write the equation 5x plus 4x plus x equals 40 and solve that for x. And I get that x is 4. Now the problem is asking me to find the length of IK, that piece here, which is made up of 4x and x. So if IK is 4x plus x, that would be 5x, and I just found that x is 4, so the length of IK is 20. Okay. On the second one, point S is on line segment RT. So I'm going to go ahead and draw that first. I've got a segment RT with a point S on it. And then I'm told RT is 4x. ST is 5x minus 10. And RS is 6. Determine the length of ST. So again, in order to do that, I need to solve for x first. I can see that these two smaller pieces are adding up to the larger. So I can write the equation 6 plus 5x minus 10 equals 4x, and then I'm going to solve this for x. So on the left side, I can combine 6 and negative 10. That's going to be negative 4. I'm going to go ahead and combine my like terms. And then divide by negative 1. And again, I find that x is 4. Happens to be a coincidence. Now, if I want to find the numerical length of ST, I just need to now plug in 4 for x here. So that's going to be 5 times 4 minus 10. 20 minus 10 is 10. Okay, now let's look at some angle problems. If angle ABC is a right angle, that means it's equal to 90 degrees. And angle 4 and 5 are in the ratio 2 to 3. Find the measure of angle 4. Now remember, when you see ratio like that, you just want to add x's to the end of that. And so we're going in this order 4 to 5. So that means 4 is 2x, 5 is 3x. And I can now write the equation 2x plus 3x equals 90, because those two smaller angles are forming my larger right angle. And I get that x is 18. So if I want to find angle 4, I'm just going to plug that in. 4, 2 times x, which is going to give me 36 degrees. Okay, and then last but not least, angle 1, 2, and 3 are in the ratio 4 to 1. So that's going to be 4x, 2x, and x. Find the measure of each angle. Well, I can assume that these 3 angles are forming a straight angle, which is 180 degrees. So 4x plus 2x plus x is 180. can solve this. And unfortunately, I'm not going to get a pretty number. I'm just going to round this to 1 decimal place. And that's going to be 25.7. So now that I know x is 25.7, angle 1 is 4 times 25.7, which is 102.8 degrees. Angle 2 is 2 times 25.7, which is 51.4 degrees. And angle 3 is just x, 25.7. And that concludes our 1.5 notes.